Let's talk about naming covalent compounds. Get out your science notebook. Here's the essential question. How do we write the name and chemical formula for covalent compounds? Let's go back and remind ourselves a little bit about ionic and compounds, and let's relate them to covalent compounds. You might remember that ionic compounds are typically between a metal and a nonmetal, and we use their predictable charges in order to write their formulas. Once their formulas are written, we can name them, typically the metal first, here in examples of magnesium, followed by the nonmetal named chloride. Now, covalent compounds work a little bit differently. Here are two examples of covalent compounds you're probably familiar with. The first one, CO2, is carbon dioxide, and the second one, CO, is carbon monoxide. Now, notice between the two, ionic compounds are pretty predictable. Their charge determines a very specific chemical formula, and their names are very straightforward. Covalent compounds, on the other hand, if you notice, have many possible combinations of those same two elements. So, how do we name them? Well, here's the general covalent compound names and formula rule. We're going to start with a prefix and then list the first element, which is typically the one that's least electronegative on the periodic table, or the ones more towards the left hand side. Then we're going to use a prefix for the second element, name that element, and just like ionic compounds, name it and end it in "ide." Now, this is probably going to be very confusing if this is the first time you're ever hearing this, so just bear with me. We'll see some examples and it will make a lot more sense. Let's start with those prefix. The prefix just represent the number of each element in the covalent compound. Here's a list that's found on the back of your periodic table. Mono typically means one, like think of like a monocle or a single eyepiece. Di, like to divide something into two, it means two. Tri, like a tricycle or a triforce, is three. If you ever played Tetris, you might recognize that all the pieces in Tetris are made out of four little squares. And then the rest of them might seem vaguely familiar from math class when you deal with different types of polygons, like a pentagon, a hexagon, maybe even an octagon. All right, going down this list, we're going to use these as the prefix in the names. So let's go ahead and see if we can practice this and see if you can understand it by applying it to various covalent compounds. So let's determine the name and formula for each of these provided covalent compounds. Let's start with the first one, SO3. All you need to do is name the elements in order with the prefix to determine the amount. The first one is sulfur trioxide. Notice that we did not use mono for the first element. That's typically not what we do. We sometimes never use mono at all, but we never use it for the first element, only for the second one. So this one's called sulfur trioxide. One sulfur and three oxygens. How about CCl4? Do you think you can figure this one out? Well, this one's name is carbon tetrachloride. Again, one carbon and four chlorines. The next one, N2O9, is dinitrogen nanoxide. A little bit of a mouthful, but that's how you say that, nanoxide. So two nitrogens, dinitrogen, nine oxygens, nano-oxide. All right, I would pause this video right now and see if you can write the formulas for these last three. Did you try it yourself? I hope so. Let's see if we can write the formulas for these last three. Nitrogen trichloride. Well, I see there's just one nitrogen, and tri means three, so that's three chlorines. All right, nitrogen oxide. So nitrogen oxide looks like it's just one nitrogen and one oxygen. By the way, this one could also be named nitrogen monoxide, and that's perfectly fine too. But sometimes we don't use mono, either for the never for the first and sometimes not for the second. All right, the last one's a little bit challenging. Did you figure it out? Tetraarsenic decoxide. That is four arsenics and 10 oxygens. And that's naming. Naming and writing the covalent compound formulas are generally pretty easy if you know the prefix. Now, I said covalent compounds are generally pretty easy, but that's mostly for those binary, simple, nonmetal elements. There are a bunch of covalent compounds that are specialized. Let's start with ones that I dub the ones with street names. These are covalent compounds that just have had names that we've named them forever. For example, H2O we typically call water. That stems from an Old English or Proto Germanic word that means wet. So we've been calling H2O water forever. Sure, we can also call it dihydrogen monoxide, but we just call it water. The next one is ammonia. Ammonia, actually, the name stems from the god Ammon, an ancient Egyptian god, because they used this chemical when they did ancient Egyptian rites honoring that god. The last two might seem a little familiar. We actually saw them in when we were doing ionic compounds. These are polyatomic ions that have a specific charge. They're kind of weird covalent compounds that have a charge that we can use in ionic compounds, but they are covalent compounds in themselves because they're only made of nonmetal elements. Carbonate, or CO3 with a -2 charge, is named such because old chemists called it that because it was some thing related to carbonic acid. It was a salt of carbonic acid. Similarly, phosphate is a salt of phosphoric acid. So they have their own names respectively, and that's what we've been calling them for a long time. There's also a class of organic compounds. Here's a list of those organic compounds. Organic compounds are elements made with a backbone of carbon, and you might notice that some of these get extremely big and long because carbon is a pretty special element. There's a whole chemistry dedicated to organic compounds, including naming them, such as methane, propane, isopropanol, glucose, cyclohexane. All of these are special organic compounds, and they have their own special names. The last one is acids. Here's some examples like hydrochloric acid, sulfuric acid, and acetic acid. These are all acids that start with hydrogen and are just combinations of hydrogen and multiple different nonmetal elements. These acids are covalent compounds themselves, but they have their own specialized names and their own specialized naming system. By the way, these names and formulas will be given to you when needed. These aren't the things you need to memorize. Stick with those simple binary covalent compounds where you use the prefix and you'll be fine. These ones will be given to you when you need them. And that's it. That's covalent compounds in a nutshell, naming and writing their formulas. This is a good time to take a moment and review and highlight those key terms, ponder questions and seek answers to those questions, and summarize the essential question from these slides. Good luck.